Hello everyone, welcome to Numeric Learning. In today's video, as a part of Do Math with me, please take your notebooks and a pen and let's continue solving maths. So today we have got some 5 questions from polynomials and 1 question from real numbers. Let's go ahead and see how to do it. So the first question of the day is, you have to find the zeros of the given quadratic polynomial and verify the relation between the zeros and the coefficients. You are given the polynomial and you have to find the zeros. That is the number one task. And secondly, after you have found the zeros, you have to verify the relation between them and the coefficients. So first of all, let us find the zeros. In order to find the zeros, you have to equate the polynomial to 0. Okay, so to find zeros, you have to equate your given polynomial, which is g of x, to 0. So let's go ahead, write the same polynomial as it is. A into x square plus 1 minus x multiplied by a square plus 1 equal to 0. Let's open the bracket. So you have ax square plus a minus a square x minus x equal to 0. Right? Okay, now let's rearrange the terms and make sure you have the a and x terms together. So ax square minus, I'm going to write minus ax square as a second term so that I can take ax common out. So minus a square x plus a minus x equal to 0. So let me take ax common from the first two terms. So you have x minus a, right? And then again minus 1, if I take out common, you'll have x minus a equal to 0. So what are the factors? You have x minus a and ax minus 1. These are the two factors. Now either x minus a equal to 0, which means you have to find the value of x. X is equal to a, or if you have ax minus 1 equal to 0, you have ax equal to 1 and x is equal to 1 by a. So your zeros are, so the zeros are x is equal to a and 1 by a. These are the two zeros. So let one of them be alpha and the other one let it be beta. These are the two zeros. Now let us verify the relationship. Okay. So to verify, we know the sum of the zeros, that is alpha plus beta, is equal to minus b by a. Okay. So what is minus b by a? What is a, b and c? Again, let us take out your a, b, c. So here, if you take a look at this particular expression, right? Here, this one, I can write it as, this particular polynomial, I can write it as, say, let me write it, I'll write it below. So ax square, okay, and then plus, or you can take a minus a square plus 1 multiplied by x. Okay, so I have, what I have taken is, I have taken minus common out and then a square and then a 1. Okay, so I have taken x common out from these two terms, and the last term will be plus a equal to 0. So this is your given polynomial, because I have written it of the form ax square plus bx plus c. Okay, so the c term is a constant term which does not have any variable in it. Now let us go ahead and write what is alpha. Alpha is your a plus your beta is 1 by a equal to minus of, what is your b? Your b is minus of a square plus 1. Okay, so minus of a square plus 1 whole divided by, what is your a? A is the coefficient of x square, which is also a. Okay, so if you take the LCM, you will have a square plus 1 equal to, minus into minus is plus, again a square plus 1 whole divided by a. So LHS is equal to RHS. Okay, now let us go ahead and verify with the product of the zeros. So product of the zero is C by A. So what is alpha into beta? Alpha is your A, beta is 1 by A. So when you take the product, alpha into 1 by alpha, what you get is 1 equal to what is C? Here C is nothing but A. Here A is also A. So you will write A by A, which is also 1, right? So 1 is equal to 1, hence verified. So now like this you are able to verify the relationship between the zeros and the coefficients. Okay. So that's all. This is what you have to do. But be very careful in taking out the common here. Okay, whatever was the given question, first of all we just open the bracket and we were able to do the factorization, right? Even without doing any middle term splitting, we were able to do it. And secondly, you have to write it off the form so that you are able to extract the coefficients, that is A, B and C easily. You should be able to write it off the form ax square plus bx plus c. So only these are the two things which are very important in this particular question. So please do it and try to do it on your own. Okay, make a note of the question and try to do it on your own, and let's then verify if you're also getting the same. Okay, let's move on to the next question. Here, you are given a polynomial x square minus root 3 plus 1 into x plus root 3. Again, let's find the 0. So, to find the 0, you have to put f of x equal to 0, right? To find the zeros, you can equate or put your f of x, the given polynomial, to 0. So, x square minus root 3 plus 1 into x plus root 3 is equal to 0. Okay, so open the bracket. What do you get? X square minus root 3x minus minus into plus is minus x plus root 3 equal to 0. Take x common out. You'll have x minus root 3. Again minus 1 common out. X minus root 3 equal to 0. So x minus root 3 is common. And the leftover to the left, what is left is x minus 1 equal to 0. So x minus root 3, either of the factor you can equate it to 0. Either x minus root 3 is 0 or x minus 1 equal to 0. So x equal to 1 is one of the 0. X equal to root 3 is the other 0. Again, let one of the 0 be alpha, let the other 0 be beta. Okay, let us also write the coefficients here. What is your A? From the given question you can say your A is going to be 1. Okay, these are the coefficients. Your B is nothing but minus of root 3 plus 1 from the given question, and your C is nothing but root 3. Now let us verify. So to verify, we know the sum of 0 equal to minus B by A, and your product of the 0 is nothing but C by A. Okay, so alpha beta is equal to C by A. So what is alpha plus beta? Root 3 plus 1 is equal to minus of, what is your B? B is minus of root 3 plus 1 whole divided by A is 1. So minus into minus is again plus. So you'll have root 3 plus 1. So root 3 plus 1 is equal to root 3 plus 1. LHS equal to RHS. What is the product of the zeros, right? This is the verifying the product of the zeros if it is equal to C by A. What is alpha? Root 3 multiplied by what is your beta? 1 equal to what is your C? C is root 3. A is 1. So root 3 equal to root 3. Hence verified. Okay, just write here. Hence verified. That's all. Okay, so you have verified, you have found the zeros. What are the zeros here? So these are the zeros. Root 3 and 1 are the zeros. Okay, so it's very easy. It's just that you need to practice these kinds of questions yourself. Always remember, whenever you are given a polynomial and whenever you have to find the 0, equate it to 0 and then expand it see if you can take a common factor out and then proceed. Let's move on to the next question. Yeah. The question is, if alpha and beta are the zeros of your polynomial f of x equal to x square plus x minus 2, then evaluate. That means find the value of 1 by alpha minus 1 by beta. The minute you are given that alpha and beta are the zeros of the polynomial, so you are given solution. F of x is equal to x square plus x minus 2. Right? So what is the alpha plus beta equal to minus b by a? So what is minus b is just 1. What is alpha beta? C by a. C is nothing but minus 2 by 1. So these two we know. What you have to find? 1 divided by 1 by alpha minus 1 by beta. Take the LCM alpha beta. So what will be the numerator? You will have beta minus alpha. Right? Okay. So there are multiple ways of doing it. Okay, we don't know what is alpha minus beta or beta minus alpha. So what we can do is, let us go ahead and find what is the value of alpha and beta using middle term splitting. Okay, so you are given x square plus x minus 2 equal to 0. So what is your sum and the product value? Sum is plus 1, your product is minus 2. So 2 ones are 2. If you put a negative to 1, you will get. So you can do middle term splitting and get what is the alpha and beta values. What is it? X square plus 2x minus 2 equal to, I'm just doing the middle term splitting. Take x common out, x plus 2, take minus 1 common out, again x plus 2 equal to 0. So what are the factors? One is x plus 2, the other one is x minus 1 equal to 0. So the zeros are either x is equal to minus 2 or x equal to 1. These are the zeros, right? Now, there are two scenarios. When you have your alpha is minus 2, then beta is equal to 1. This is number 1. When alpha is 1 and your beta is minus 2. For both the scenarios, let us calculate what is this particular value. Okay, beta minus alpha. So what is this here? Let's just substitute. What is beta? Beta is 1 minus. I'm just substituting alpha, beta values. See, either minus 2 can be alpha. In that case, beta will be 1. Or your alpha can be 1, beta will be minus 2. In both the scenarios, let us calculate this value. Okay. So, here beta is 1 minus, what is alpha? Alpha is minus 2. Divided by minus 2 into 1. So, this is nothing but 1 plus 3. 1 plus 2, right? 1 plus 2 divided by minus 2. So, this is nothing but minus 3 by 2. Okay, this can be the answer. Or what is beta? Beta is minus 2. Minus 1 whole divided by 1 into minus 2, which is minus 2. So, it's nothing but minus 3 by minus 2. Minus minus gets cancelled. So, you have 3 by 2. So whenever, so in this particular, both are the answers. Either it is minus 3 by 2 or 3 by 2. Both can be the values of the given expression. That is 1 by alpha and 1 by beta. Okay. So you can write the answers as minus, plus or minus 3 by 2 is your final answer. Let's go ahead and do the next question. So here, in this particular question, this is a very, very important question from your first chapter. Listen carefully. So the question is, find the greatest 6-digit number that is exactly divisible by 24, 15 and 36. So what is tell me the greatest 6-digit number. Greatest 6-digit number is actually 6 nines, right? 9,99,999 is your greatest 6-digit number. Now, you have to find the greatest 6-digit number which is exactly divisible by these three numbers, right? Now, in order to find that, First of all, let us find what is the smallest possible number which is divisible by all these three numbers. Okay. So what is the smallest possible? Least, you have to find the least common multiple, right? So whenever that number will definitely be greater than 24, 15 and 36. So you have to find the smallest number which can be divided by all the three numbers perfectly. So that number will obviously be greater than all these three. That's why you have to find the LCM. Okay, so the first thing is let us find the least common, smallest possible number which is divisible by all these three. So LCM of 24, 15 and 36. Okay, so you have to do the prime factorization. For 24, it will be 8 into 3 is 24. 8 I can write it as 2 cube multiplied by 3. 15 I can write it as 3 multiplied by 5. And 36 I can write it as, say, 9 fours are 36 or 4 nines are. So 4 I can write it as 2 square, 9 I can write it as 3 square. Now let me make these factors common. So here it will be 2 to the power 0, here it will be 5 to the power 0. So whenever you are taking the LCM, you have to take the highest power of all the prime factors. So for 2, what is the highest power? 2 to the power 3. For 3, what is the highest power? 3 square. And for 5, it is 5. Right? So here you have 2 cube, 8 multiplied by 9 multiplied by 5. So you have 72 multiplied by 5, which is nothing but 360. So what does it mean? 360 is the smallest number which is divisible by all these three numbers. Okay, and you have to find in the same line a greatest 6-digit number which is also divisible by 3. So obviously 360 should also be able to divide your greatest 6-digit number. So let us divide 9999 divided by 360 and let's see if it is divisible. Okay, so when you divide 9,99,999 by a number which is divisible by all the three, let us see if it is perfectly divisible. So firstly, it will go with 2. So 720, subtract, you will get 97279. Again take a 9 here, again 7. So 0, 42, 2, 4, 21, 22, 23, 24, 25. Am I making a mistake here? Just a minute. So it's 0, 42, 2, 4, 21, 22, 23, 24, 25. Okay. And then subtract it. So 9, 7, 2. Again take a 9 down. So again 7, 0, 2, 5, 2. Subtract it. You will get 9, 7, 2, 79. Again take a 9. So you'll multiply it with 7. So you will get 2, 5, 2, 0. What is the remainder here? 279 is the remainder. Now, if you subtract the given number by the remainder, so this is your given greatest number, the minus, if you subtract it from this remainder 279, right? The given number with the remainder, you will get a number which is divisible by 360. And if that is a number which is divisible by 360, obviously it is perfectly divisible by 24, 15 and 36. So when you subtract it, what do you get? You will be getting 9,99,720. So this is the number. This is the greatest 6-digit number which is exactly divisible by 360. Right? This is the greatest 6-digit number which is exactly divisible by 360. So if you divide 999,720 divided by 360, your remainder is going to be 0. And if it is divisible by 360, obviously it is divisible by all these three numbers. Why? Because 360 is the smallest number which is divisible by all the three. Therefore, this number, right, 9,99,720 is the greatest 6-digit number which is exactly divisible by 24, 15 and 36. Okay. Oh, now let me give you a homework. Okay. You should try your question. Find the greatest three-digit number which is exactly divisible by 4, 6 and 8. This is your homework. How will you do it? You know that the greatest 3-digit number is going to be 999, right? And in order to find a number which is divisible by all the three, what is the smallest number which is divisible by a number which is divisible by all the three will definitely be greater than 4, 6 and 8. So what you will do is you will find the LCM of 4, 6 and 8. Right? You will get some number x. Then what will you do? Okay, then you will divide whatever the LCM you are getting, 999 divided by x. Okay, and when you divide, you'll be getting some remainder. Okay, so let that remainder be capital R. After that, what will you do? You will subtract the greatest 3-digit number minus the remainder that you have got, which will be giving you the answer. Okay, so this will be the greatest 3-digit number which is divisible by 4, 6 and 8. So do try it out and you will comment your answer. Okay, do try it and let me know what answer you are getting. Okay, so this was it, today's practice, and in Hindi we call abhyas, means practice. So every day when you practice maths, you are in touch with the subject, you are revising the concepts, and we have been doing for the past 8 days, and today it was day 19. I am sure this is helpful for you. Do leave a comment below for me to understand how my videos are helpful. Are you able to understand clearly? Is there any topic that you are finding difficult in real numbers and polynomials? And also, let me know the toughest topic that you feel. Any topic that you feel is the toughest or any concept that you feel is toughest, please drop it in the comments and I'll definitely respond. Also, do join me every Sunday 6 to 7 p.m. IST for a live session that will happen every Sunday from 6 o'clock to 7 p.m. wherein we will be solving some important questions related to both these chapters, and as of now it is only chapter 1 and 2. I will be starting your chapter 3 which is linear equations from in the coming weeks. Okay, so do join me live on YouTube on Numeriq Learning 6 to 7 p.m. IST every Sunday. Till then, happy learning, keep practicing, keep solving, come up with more questions and if you have any. Okay, enjoy the subject. Thank you. Do share and please do subscribe.